Good day, everyone. We are Group 4 and we are here to discuss the assigned topic, which is the composite materials. So, we are the presenters. I am Miss Liwag together with.
And I am Joel Mercandez.
And I am Elner Pedrajas.
And I am Christian Joy Clarete.
Okay, let's move to the main objectives of this topic. So, the first one is understand the basics of composite materials. Second is learn about the classification of composites. Third is understand the properties and processing methods of polymers matrix composites. And the last one is learn about the other composites. So let's start the introduction to composites. The heterogeneous combination of two or more materials is called a composite material. The constituent material differ in form or composition on a microscale. The materials that are added to the parent material may be reinforcing elements, fillers, and or binders. So in this slide, says that the composite materials are formed by two combining or more materials that have a quite different properties or nabubuo ito sa pamamagitan ng pagsasama-sama ng dalawa or higit pang mga materials na may magkakaibang katangian or uri or composition na magre-resulta ng bago at kakaibang object. So ang composite materials is made by human. Let's say in the market. Kaya tayo nagkakaroon ng intelligent product because to meet the customer's demand. For example is yung material A and material B. Pag pinagsama sila, ang kalalabasan is yung intelligent product. So that's why nagkakaroon tayo ng product na makikita sa market at makatulong sa pang-araw-araw nating pamumuhay. The composite material will be designed in such as a way that it maximizes specific performance properties. The added materials will be not dissolved or merged completely and therefore normally exhibit an interface between one another. So, syempre, magdi-design or i-design yung composite materials para makatulong or mapakinabangan natin sa ating lipunan. Kasi matrabaho ang ganito at may chemical involved sa work na ito. The composite can be strong and stiff. Pwede rin siyang maging lightweight because of two combining materials. So, next is about naman ito sa example ng composite. Some examples are wood or cellulose fibers in a matrix or lignin and hemicellulose. So first, yung wood. Yung lignin ay makikita sa cell ng plant. Example dito is yung fiberboard, hardboard, plastic, wood plastic, composite, and wood cement composite, and etc. And second one is yung concrete or sand, cement, and stone. For this naman, it is considered as a composite materials. It is the most used in construction at the same time. Di ba kapag gumagawa naman tayo ng bahay, hindi naman pwedeng sand lang yung gamitin natin. Kasi magiging mahina yung foundation na magagawa natin. So, but kapag pinag-combine natin yung tatlong yung sand, cement, at yung gravel, merong maganda yung outcome niya. Sobrang tibay at hindi basta-basta magigiba or masisira. Then the last one is yung fiber reinforced plastic or polymer with glass or carbon fibers. So dito naman, it is made by polymer. The fiber is usually used with glass, carbon, and aramid. Yung example naman nito is yung signboard, bridge, deck, yung pipeline for gas and sewage. At saka yung mga sports equipment like tennis racket, golf club, sharp, at helmets, at yung bow and arrows. The next one is the nature has been using composites quite intensively. Bone is a good example that is made of hydroxyapatite or mostly calcium phosphate, which is hard but brittle, and collagen or protein, which is a soft and flexible material. The combination of the two gives the combination of two gives the ability for the bone to support the body. Hindi naman yung composite materials is hindi lang yung pang outdoor materials. Ito ay nag-exist din for natural composite for both animals and plants. Eh di yung, like yung wood, di ba, isa yung composite. It is made long cellulose fibers. Ito ay much weaker substance called lignin. Yung cellulose is found in cotton. But without lignin, nakasama, it is much weaker. Pero pag pinagsama yung dalawang weak substances, which is yung lignin at yung cellulose, magiging stronger sila. Then yung about naman sa bone, natin, isa din yung example for composite. It is made for hydroxyapatite na inorganic mineral na meron sa human bone at sa ating teeth. Ang role naman nito is for structural strength of bone to bone regeneration. Siyempre, to support our body. Next is human have also been making composite for thousands of years. Mud brick used as the building materials as a good example of a composite. Mud has been found to be a good building materials because of its good compressive strength. So, basahin ko na din to kasi connected sila. However, it lacks any tensile strength to compensate for that. Straw has been added with has good tensile strength but poor compressive strength. By combining the two, early humans have been making excellent building blocks for residence structure. So ito naman, people have been making composite for many thousands of years. So in early example is yung mud bricks. Mud can be dried out into brick shape to give a building material. It is strong if you try to squash it. It has a good compressive strength. But it you will break quite easily if you try to bend it. It has poor tensile strength. But and yung straw seem very strong if you try to stretch it, but you can crumple it easily. By mixing mud and straw together, it is possible to make bricks that are resistant to both squeezing, tearing, and make excellent building blocks. So let's move in the 6 different types of composite. The first one is laminate. Composites in which layer of different materials and bonded together with adhesive to give added strength, durability, or some other benefit. So dito naman, example naman dito is yung plywood. At pwede ding example dito is yung furniture. Kasi it is impervious to environmental factor and is resistant to scratches and stain because of its durable sealed surface, and the furniture is also easy to maintain. The next one is the reinforcement with long fibers. Composed of axial particulates embedded in a matrix material. The object of fiber reinforced composite is to obtain a material with high specific strength and high specific modulus. So dito naman, the three of the most crucial characteristic of long fiber composites are stiffness, strength, and durability or toughness nito. With reinforcing fibers at a higher aspect ratio, the long fiber composite have more strength, which allows them to withstand deformation and resist creep under heavy load. And the next one is particle reinforcement. Particle reinforcement consists of a matrix reinforced with a dispersed phase in the form of particles. The type, shape, and spatial arrangement of the reinforcing phase are the key parameter in determining the mechanical behavior of the composite. It is the type of composite that uses tiny particles. It is destructed in a wide area. The particle is characterized by the equal dimension in all directions. Ang example naman nito is yung mga automobile tires. Yung at yung concrete then kasi the aggregate of the coarse rock or gravel is embedded in a matrix of cement. The aggregate provides stiffness and strength while the cement acts as the binder to hold the structure together. The next one is the randomly arranged continuous fibers. Composites that have long aspect ratios with a random orientation. It generates differ fiber distribution with fast speed and good randomness. Ang example naman nito is yung wind turbine. Like sa ginagamit for power generation, ganon. At saka yung sa boat. For short fibers naman. Short fibers are used as a structural materials as they provide superior mechanical properties and can be easily produced by the rapid, low-cost injection molding process by extrusion and with spray-up techniques. So, ang example naman nito ay yung mga bumper ng mga sasakyan at yung mga toys na gawa sa plastic. Like yung Lego, di ba? Plastic yon. Kapag natapakan or nagpatak ito ay madali siyang masira at madedeform. Yun yung tinatawag na low-cost injection molding process. So, the last one is the woven fabric mat. Are flexible, able to be tailored to be specific
These are
needs, and have
composed
better
of
mechanical
different
properties
provided
due to their weaving structure. So it is advanced textile composites such as woven, braided, knitted, and stitched fabrics. It is increasingly being used as structural
polyester
materials in
or thermoplastic,
the industrial
such
application
as
due to their
polycarbonate,
efficiency at
polyvinyl
reinforcing more
chloride, nylon,
direction
and
within a single
polyester.
layer in their
The
ability to conform
dispersed
to
materials
surface with
is
complex curvatures. Ang example naman nito is yung carbon fiber cloth at yung mga body parts ng mga race cars and some automobiles at yung airspace like planes and rockets. So, yun lang.
Thank you, Miss Eloisa. For the continuation, composites are improving the design process and end products across industries, from aerospace to renewable energy. Each year, composites continue to replace traditional materials like steel and aluminum. As composite costs come down in design flexibility, improves fiber reinforced composites like carbon fiber and fiberglass open up a new design opportunities for the engineers. Now let's talk about the advantages of composites. Lightweight but strong. Normally, express as strength to weight and stiffness to 8 ratio straight divided by density. When used as a structural material in automobile or aeroplane, composites provide higher performance coupled with sustainable fuel saving. Lightweight but strong, composites have a high strength to weight ratio. Perhaps the biggest advantages of composites is their high strength to weight ratio. Carbon fiber weigh about 25% as much as steel and 70% as much as aluminum, and is much stronger and stiffer than both materials per weight. High-end auto engineers use composites to decrease vehicle weight by as much as 60% while improving crash safety. Multilayer composites laminates absorbs more energy than traditional single layer steel. Design flexibility. Many of the composites manufacturing methods allow for molding into complex shape as required. For example, it is possible to achieve complex double curvature parts with a smooth surface finish in one manufacturing operations. Composites offer design options that would be hard to achieve with traditional materials. Composites allow for part consolidations, as a single composite part can replace fully assembly of metal parts. The surface textures can be altered to mimic any finish, from smooth to textured. Over 90% of recreational boat hulls are constructed from composites. It's part because fiberglass can be molded into wide range of boat shape, kasi mas madali siyang namomold, hindi tulad ng ibang mga metals. Excuse me. These benefits save production times and reduce maintenance costs in the long run. Adapt a particular use. Tailor making the properties for a given applications by carefully choosing appropriate combinations of matrix and reinforcement materials in its manufacturing method. Design flexibility is composites offer designs of options that would be hard to achieve with uh, adapt for the particular use is composites can be molded into different complex shape, which can be the replace multi-unit assemblies, consolidating then assembly processes. Kaya nga ang composites materials are generally used for buildings, bridges, and structures such as boat hulls, swimming pool panels, racing car bodies, shower stalls, bathtub, storage tank, imitation to granite and cultures marble sinks and countertops. And they are also being increasingly used in general automotive applications. Various structures. Designing and fabricating complex geometry in a single operations, reducing the part count. Sabi dito that in the past, an engineer had to use a complex layout process that fabricate composites, which was time-consuming and restricted the design geometry. Digital Composites Manufacturing, or DCM, uh, has changed. DCM is a patent manufacturing processes that fabricates composite parts without manual labor. With DCM, composites can be tailored in three-dimensional locally or globally, creating just the right strength, density, and flexibility for a project. DCM is enabling engineers to design for the flexibility of 3D printing combined with the high performance of composites. Now let's move to the next slide. Efficient and economical, reducing the production cost for a specific product, as there are a wide range of composites manufacturing processes available. Because composites are corrosion resistant, products made from them last longer. Kaya nga mas pinipili ng mga ibang engineer ang composites over traditional materials to reduce maintenance costs and ensure long-term stability, major benefits for structures that are designed to last decades. Alam nyo ba noong 1963, ang composites gasoline tank was bored in service station in Chicago. When it's dug up, nung hukay nila ito 20 years later, the tank was in good condition, showing no signs of leakage, structural distress, or corrosions. Sabi nga nung ibang expert that the tank could last another 25 years. So isipin mo yung kung gaano katagal na pwedeng gamitin yung composites materials. Weathering properties. Composites are less likely to break under stress. If a crack is formed, it will be not spread like a piece of metals because it will be blocked by the fibers. Hindi siya tulad ng mga steels na once na nag-crack ay dire-diretso na yon. once na nagkaroon ng stress, parang na-stretch yung steel. So sa composites are hindi ganoon ang mangyayari kasi meron pa ring magbablock or magho-hold dun sa crack kasi may mga naka-align na fiber reinforced para mas maging matibay yung composites. Thermal and chemical resistance. Generally, composites offer excellent resistance to heat, corrosions, chemical attack, and outdoor weathering. At composites never rust, regardless of their environment, though they are prone to corrosions when bounded into metal parts. Composites have less fractures toughness than the metals, but more than most polymers, their dimensional stability allow them to maintain their shape whether hot or cold, wet or dry. This makes them the popular material for outdoor structures like wind turbines, blades. Kaya mas nakakadalasan natin 'tong nakikita sa mga wind turbine kasi nga, hindi siya katulad ng metal na nagkakaroon ng corrosion, tsaka hindi siya madaling tinatamaan ng iba-ibang mga chemicals na maaaring makaapekto. And the last one is recyclable. A lot of waste materials can be recycled during a composites manufacturing processes. Now let's move to the next slide. Now let's talk about naman the disadvantage of composites. Many of the constituents of composite materials are expensive and careful selections need to be made to control the cost involved. Yun nga lang, yung downside naman ng composites are yung ibang materials niya is napakamahal talaga na na mas mahal pa sa ibang mga materials. So, kailangan piliing mabuti yung mga materials na gagamitin mo para hindi masyadong lumaki yung gastos mo. The second disadvantage of these composites are repairing of composite is not an easier task, particularly for doing on-site. Ito yung napakahirap sa composites kasi once na ma-deform or magkaroon ng sira yung composites ay hindi mo siya agad-agad mare-repair on-site. Hindi tulad ng mga steels or metals na once nagkaroon ng deformations or nagkaroon ng sira ay once napukpukin mo lang or gamitan mo ng some spores ay pwede mo na siyang ma-repair. Depending upon the composites and specific processings involved, it is original manufacturers. Not all facilities such as hot curing may be readily available on sites. Yun kasi yung ibang mga, for example, gumagamit ka ng composites materials, ano na yan, aftermarket mo na mabibili. Bibili mo siya sa ibang ang manufacturer. So, once na nagkaroon ng problema yung iyong composites materials, ay ibabalik mo siya sa manufacturer para doon nila ma-repair. Kasi wala ka naman, for example, hindi ka naman siguro bibili ng mga hot curing machine na para ma-repair yung binili mong composite. So, need mo talaga siyang ibalik sa manufacturer kasi sila yung knowledgeable sa pag-repair at paggagawa ng mga composites. And
Thank you po, Kuya Hill. So, let's move to classification of composites. So, we have now classification based on matrix. So, first, we have A, which is polymer matrix composites, or PMCs. So these are composed of matrix from either thermosetting resins such as epoxy or unsaturated polyester or thermoplastic such as polycarbonate, polyvinyl chloride, nylon, and polystyrene. The dispersed material is the fibers such as glass, carbon, steel, or Kevlar. These are the most commonly used type of composites. So a polymer matrix composites or PMCs is a composite materials composed of a variety of short or continuous fiber bound together by a matrix or organic polymers. So PMCs are designed to transfer loads between fiber or matrix. So some of the advantages with PMCs includes their lightweight, high resistance, um, high resistance to abrasion or corrosion, and high stiffness and strength along the direction of their enforcement. So we have the function of the matrix in PMCs is to bound the fiber together and transfer load between them. So PMCs matrices are typically either thermosetting, which as I mentioned earlier in the description, or thermoplastics. So thermosetting are by far the predominant type we are using today. So thermosetting are subdivided into several resins. So this includes epoxies, phenolics, polyurethanes, and polyamides. And of these, epoxy systems currently dominate the advanced composite industry. So we already discussed the thermosetting. So we will discuss again. Thermosetting resins require addition of a curing agent or hardener and impregnation onto a reinforcement material. So followed by a curing step to produce a cured or finished part. Once cured, the part cannot be changed or reformed except for finishing. So thermoplastics currently represent a relatively small part of the PMC's industry. They are typically supplied as non-reactive solids, or we should say no chemical reaction occurs during processing. So, and require only heat and pressure to form the finished part. Unlike the thermosets, the thermoplastics can usually be reheated and reformed into another shape if desired. So next we have B, um, metal matrix composites or MMCs. So matrix composites are generally used to provide specific properties to the composites such as improving creep performance, resistance to higher temperature, improve dimensional stability, increase abrasion resistance, or decrease the density. So about 75% of the MMCs are particulate composites while other are fibrous composites. So a metal matrix composites is a composite materials with fiber or particles dispersed in a metallic matrix such as copper, aluminum, or steel. So the secondary phase is typically a ceramic such as alumina or silicon carbide or another metal such as steel. They are typically classified according to the type of reinforcement. Short discontinuous fiber, continuous fibers, or particulates. I mean, again, MMCs uh, are made by dispersing a reinforcing materials into a metal matrix. The reinforcement surface can be coated to prevent a chemical reaction with the matrix. For example, carbon fibers are commonly used in aluminum matrix to synthesize composites showing low density and high strength. So these are composed of a metallic matrix such as aluminum, magnesium, iron, etc. So with a dispersed fiber that could be either metallic or ceramic. So the metallic fiber examples are tungsten, molybdenum, lead, and etc. So the ceramics reinforcement are oxides and carbides such as cemented carbides and other cerments. Next, we have ceramic matrix composites or CMCs. So, ceramic matrix composites improve toughness of the conventional ceramic materials, which are brittle by adding carbides and oxides in the dispersing phase. The reinforcements added act as a barriers to crack propagations. So the fiber used are carbon, silicon carbide, oxides, and silicon whiskers. So in ceramic matrix composites are a subgroup of composite materials and a subgroup of ceramic. They consist of ceramic fibers embedded in a ceramic matrix. The fibers and the matrix both can consist of any ceramic materials, whereby carbon and carbon fibers can also be regarded as a ceramic materials. So these are composed of ceramic matrix such as silicon and which is silicon embedded with fibers. These are specifically used for high temperature application. These are less commonly used compared to other composites. Okay, let's move to the another slide. So we have matrix composites. So the matrix phase used in PMC can be classified as thermosetting resins or thermoplastic resins. Thermosetting resins are the most commonly used resins in the commercial PMCs, which is I already mentioned in my explanation earlier. And this includes epoxies and polyamides, though epoxies are the most widely used resins. These materials during the curing phase cross-links and polymer chains, thus providing a three-dimensional structures and stability to the polymers. So as I mentioned earlier in my discussion about PMCs, or about matrix, which is about thermosettings, resins, and thermoplastics. That the function of the matrix in PMCs is to bound the fibers together and transfer loads between them. So PMCs matrices are typically either thermosets or thermoplastics. Thermosets are by far the predominant type that we are using today. So these generally have better dimension stability and good resistance to high temperature. Thermoplastics resins used includes polyester, polyphenyl sulfide, polyamide, amide, and others, etc. Though these are not as good as thermosetting resins in terms of their high temperature resistance, these are easier from the manufacturing point of view. Next slide. We have fibers. So fibers are the strong reinforcement with their strength depending upon the diameter. The various materials used are glass, graphite, carbon, aramide, nylon, metal, and whiskers. So the strengthening of the materials by the fiber depends upon the mechanical properties of the fiber. However, it is also depends upon the amount of or and orientation of fiber along with the surface interaction between the fiber and the matrix. So the fiber are commonly found and used within PMCs. So includes fiberglass, graphite, and aramide. Fiberglass has relatively low stiffness at the same time exhibits a competitive tensile strength compared to the other fibers. So the cost of fiberglass is also dramatically lower than the other fibers, which is why fiberglass is one of the most widely used fibers. So the reinforcement fibers have their highest mechanical properties along their lengths rather than their widths. Thus, the reinforcement reinforcing fibers may be arranged and oriented in different forms and directions to provide different physical properties and advantages based on the applications. Let's move to the next slides. So we have fiber as a glass. So in glass, the most common fiber used for reinforced plastic. These are generally two types, which is S glass, which is silica magnesium glass used in high strength composites, and E glass, which is borosilicate glass used in electrical installation. These are relatively easy to produce by drawing from the glass melt. As a result, these are less expensive compared to the other fibers and widely used. So the majority of all fiber used in the composites industry are glass. So glass fibers are the oldest and by far the most reinforcement the most common reinforcement in the end market applications. So to replace heavier metal parts, glass fiber weighs more than the second most common reinforcement, fiber, carbon fiber, and is not stiff, but is more impact resistant and has a greater elongation to break. Next, we have fiber in carbon. So, fiber are much stronger compared to glass with rigidity 10 times and density half. This has got higher fatigue resistance compared to glass. However, this is more expensive than fiberglass. So by far, the most widely used fiber in high performance application is carbon. So carbon fibers have several advantages: the high stiffness, high tensile strength, high strength to weight ratio, high chemical resistance, high temperature tolerance, and low thermal expansion. Next, we have polymeric. So polymeric fibers are have a low density, low stiffness with medium to high strength. So polymeric fiber are a subset of artificial fibers which are based on synthetic chemicals rather than arising from natural materials by a purely physical process. Next, we have metallic. Fibers are heavy and are relatively less expensive. Because of their higher density, they are much preferred. So, metallic fibers can be drawn from ductile metals such as copper, gold, or silver, and extruded or deposited from more brittle ones such as nickel and aluminum or iron.
So, thank you, Mr. Elner Pedrajas. Moving on to the final topic, we have uh, the classification of composites. So, itong classification na to is based on the dispersed material. So, as you can see sa figure, there are a lot of classification and types of dispersed materials. So firstly, we have structural. So what makes structural composites unique to others is that it is the only one with a compressed, multi-layered constituent materials. We have two types of structural laminates and sandwich panels. So laminae are stacked and bonded in proper arrangement such that the orientation of fiber direction varies successive layer, allowing it to withstand the loads much better. This provides a balanced in-plane stiffness. So, laminates, yun daw patong-patong na ply or yung tinatawag nating laminate provides the composite its high tensile, compressive, and torsional strength. Since ang examples nito is carbon, glass, and aramid, pwede siya gamitin sa aircraft, automotive, and mga infrastructure sectors dahil nga matibay siya. Next is sandwich panels. The construction of sandwich panel is such that two strong faces, steel or aluminum, are provided with a lower density, strong core in between. The core is generally of honeycomb structure to provide large bending stiffness. The faces and the core are bonded properly so the load can be transferred between them. So, sandwich panels are lightweight beams having relatively high application stiffnesses and strengths. So, as you can see sa figure, merong skin or face na nagproprotekta dun sa inside material, adhesive para masecure ang pagkaka-attach, and the honeycomb core which acts as the support to handle the bending loads. So, sabi daw, kapag na-bend ang sandwich panel, one face experiences compressive strength and the other naman is tensile stress. I mean, compressive stress and the other is tensile stress. So, tulad kanina, it can also be used in aircraft, automotive, and construction. Next, we have fiber reinforced composites. The reinforcement is in the form of a fiber. Fibers used as generally glass Kevlar, DuPont's trade name for aramid fiber, or carbon graphite. So, ang DuPont is a company that produces science-based products like aramid fiber na, ayun nga, sabi kanina, na pinangalanan nilang Kevlar. So, ano nga ba ang Kevlar? It is a synthetic fiber used for manufacturing or mainly sa mga protective gears like helmets and bulletproof vests. So, fibers being strong in tension provides a large improvement in strength for fiber reinforces composites materials. An example of widely used material is the fiberglass that is continuous glass fibers in the polymer matrix. The other type of fibers used are whiskers, which are the thin, single crystals that have large length to diameter ratios. These have very high strength but are very expensive and difficult to manufacture. Examples nito ay graphite, silicon carbide, and silicon nitride. So under naman ito ang continuous fiber reinforced composites and short fiber reinforced composites. So dito madali lang ma-distinguish ang dalawa kasi when we say fiber, thin strand siya na in this case ay ni-reinforce para maging mas matibay. Ngayon sa continuous fiber reinforced composites, yung thin thread na yon ay pinuputol lang mahaba enough to fill or para magkasya dun sa matrix in an aligned orientation. So it can be used sa mga matte structures at ginagamit din ito ngayon sa mga 3D printing. On the other hand, discontinuous aka the short fiber reinforced composites naman ay pinuputol into tiny pieces na sabi nga dito ay less than 100 times the diameter. Utilized naman ito sa mga steel wires and heavy duty truck tires. So kung sa continuous ay aligned lang ang fibers. Dito naman sa short fibers as we can see sa next slide. Ayan. So maaari siyang maging aligned or randomly oriented. And lastly, we have particle reinforced composites. These are relatively simpler composites because of their production and forming. The dispersed phase is in the form of particles that are distributed in the matrix, providing the reinforcement. These are less effective compared to the fiber reinforced composites. They increase strength and stiffness and are normally utilized where high wear resistance is required. The main advantage of reinforced composites is its low cost. An example is the concrete paved roads for low maintenance roads. So, ang under naman nito is large particle reinforced composites at ang dispersion strengthened particle reinforced composites. So, uh, large particle, the particle size used in this composite is relatively large. The reinforcement capability is indicated by the bonding of the matrix and particle. Sa dispersion strengthened particle naman, the particles are very small in size, less than zero point 0.1 micromole, or it ranges to 10 to 100 millimeter in diameter. By uniformly dispersing the particulate, the strength is increased. The materials used can be metallic or non-metallic oxides. The strength increases with the increase in volume fraction of the particulates. So, base nga dun sa example kanina na concrete, the mixture of sand, cement, and water ang bumubuo dun sa matrix. And the gravel functions as the reinforced particle. So, sabi sa definition kanina, it is not as strong as the other composite dahil very small lang ang nagkokos ng hindi masyadong pagka-intact nila since particles nga lang sila. Nonetheless, fit pa rin naman itong gamitin because it has the capability to resist the progressive loss of volume or yung wearing na tinatawag. Sa large particle reinforcement naman is used with all the three major types of materials, namely metals, polymer, and ceramics. Its examples are, ayun nga, so yung concrete, automobile tires, ceramic metal composites, which is also known as cermets, na may ability na mag-undergo ng deformation. When we say dispersion strengthened composites naman, ma-achieve daw yung strength niya due to its the interaction between the particles and dislocations within the matrix. Prime example nito ay ang thoria dispersed nickel that has the resistance to high temperature oxidation. Ayan. And that would be all for the topic of composites. Thank you all for listening and have a great day.